Hey everyone, it's Jim
and Charles
from Mellow Amps, and in this episode
we're going to do something exciting.
Yeah, we're going to put the fuses in, and then we're going to do startup testing. So I've actually pulled an IEC because it's hard to see. So here is your primary fuse holder. Now this is going to depend on what voltage region you're in. So
for North America, we have 1 amp fuses for 120 volt region.
And for the high voltage region, 220 to 240 volts, it's going to be half of that. So it'll be 500 milliamps.
Now we supply it with 2 fuses in case you have an issue with one of them, and the spare can actually tuck inside here.
Yeah.
There we go.
Yep. And then you just load it in and
I think you turned around. There we go.
Yeah. So let me just get it on camera so you can see. So this little tab here kind of guides it in. And then there. And Bob's your uncle. Okay. Go ahead and pop your fuse in. Okay. So go ahead and grab your envelope of 250 milliamp fuses. Everybody, it doesn't matter what voltage region you're in, will use the same fuse. And they just pop in here. Now, we're still installing things, so you will never have put an IEC power cord on here and turn this on just for fun, right? Okay.
And you don't currently have one plugged in while you're poking around with meaty fingers.
Yeah, absolutely not. And there we go. Okay, now for testing purposes, I'm just going to leave the covers off, but once you're done testing, the covers can go on. And yeah, okay, let's get set up for testing. Okay, so it's time to start up the amp. So before you put your IEC cord in, let's get everything organized. So go ahead and grab your power supply schematic. We're going to be probing initially on the first startup test points 3 and 4. And if we read the note attached to them, note 8, it's going to tell us that what the value will be with tubes in, but we're not going to load tubes. No tubes for the first startup. We're going to be looking for something in the ballpark of 325 volts DC. So set your meter to DC.
There we go. We've got it on DC here, and we have this nice green clipper here for the ground.
Let me repeat, there's no IEC connected to your preamp, and you never work inside a preamp with it live on or even the IEC cord connected.
And if it has been plugged in or connected or anything like that, the capacitors need to be discharged, and we'll show you how to do that in a second after we do our first startup test.
Okay, and let's show them the probe that we're going to use on the positive side. Notice how I've put a little bit of shrink here so that you can't easily short out that long length of conductive material. Okay, so IEC plug.
Well, first, before we get it in there, let's familiarize ourselves where test point 3 and 4 are, and they are right here on the board. We've got 2 points. Sorry, I'm kind of shading it here. We've got 2 points right here that we have a component soldered to on the other side, and that's where we're going to be probing.
Yeah, and you want to show proper procedure for holding a probe when you're going inside an amp.
You want to keep your fingers back on it. And you want to slowly go in here, and you want to make sure that you're not touching a ground or anything with another part of your body. And you just want to bring it right onto the probe point solidly.
Now, best practice when you're working on your bench with high voltage electricity is that you should be on a non-conducting surface. So, and in our labs, I actually have down anti-fatigue rubber mats. And we wear rubber-soled shoes, so that helps isolate us some more. But if you happen to be working, let's say, on a basement floor with a concrete surface, that's about as dangerous as you can get, because that's almost the perfect ground if it's slightly damp. So
move to another part of the house.
Yeah, or make sure that you put an isolating pad down and that you're wearing rubber soles and that you have someone around who can help you if you have a problem. But if you follow good safe procedures. As we're showing you, you should be absolutely fine. So we're going to plug in the IEC. And of course, I can't see, but I know which way it goes in. And actually, let's just move it down a little bit so people can see the moment when we turn it on. So there's no tubes in. So let's power it up.
We've got a light. Now, if you didn't have a short or an issue, that light should stay on. And now we're going to come in and we're going to probe test point 4. Carefully come in here. And there we go. We've got voltage. It's slowly climbing, and we should see it stabilize in a second here.
Yeah, no, the capacitors have never been fired up. So it takes them a little while on the very first turn on to sort of wake up. And now, when you're probing voltages for an amp that's essentially in a static electrical position, the voltage should come up and it should harden up. It should not be wandering around up and down. If the voltage is shifting up and down rapidly, that's a sure indicator that you've got a problem. But if it's climbing steadily, then you're going to be just fine. And we're almost stopped. We're actually going to just wait a minute and watch it come up.
And what do we have on the schematic there for no tubes loaded?
325 volts DC. And there's a big note on top that says all voltages are approximate.
Well, let's see how close we get here. If I can stay on that point. There. That's pretty darn close. 324.
Now, you're going to probably be a little bit more or a little less, and that's going to depend on your mains voltage.
Yeah, we're running ours off of a Variac at exactly 120 volts right now. And let's check the other channel. So that was test point 4. This is test point 3 here, and we should have something very close. 324.9.
Yeah, they're almost the same. Now, notice the voltage has hardened up, and it's rock solid steady. It's just going to climb up a tiny little bit more as the circuit stabilizes.
But it's not bouncing up and down 5, 10, 20 volts, something like that.
Yeah.
So that's a very good sign. So if you've got this here, that means your startup test has been successful and we're ready to move on to loading some tubes.
Yeah, and part of the reason the voltage was moving around a little bit was Charles was having a hard time holding...
Yeah, it's a bit of an awkward position.
Holding the probe on, keeping his hand out of your focal point so you could watch it. Okay, well that was a really good first start. So now we're going to turn off the amp and we're going to unplug it.
And we're going to show you how to discharge it. So on this amp build, we have actually a point marked. Let's go in here.
I'll lift it up and hold it.
So let me get a non-conductive poker because we haven't made it safe yet. Right here, we have some lightning bolts and some text that says discharge here with an arrow pointing at test point 2. And that is a point in the power supply where it makes sense to do a discharge. So this is our discharging tool. It's basically a resistor on a wire lead with a poker and a lot of insulating heat shrink here. So we're going to bring this clipper over to our ground carefully. And I'm going to bring the poker over to that discharge point. And you saw that little spark?
Yeah.
That was the capacitors getting discharged, and this amp is now safe to work in.
Yeah. Yeah. And of course, you wanted that IEC off so that...
Yeah. If you discharged that while the amp was on and the IEC was plugged in, you'd blow a fuse instantly.
Yeah, and it would be really exciting, so don't do that, folks.
Okay, let's get some tubes loaded.
Okay, so the sockets are brand new and they're going to be tight, and that is a good thing. You do not want loose sockets. I'm going to break them in before we start. And if you don't have a junk 9-pin, now it can't be a complete piece of garbage, so it has to be an intact tube with pins that are straight, yeah? But if you don't have a junk tube, you can always put a note when you order your kit and say, hey, Jim, can you send me a junk tube so I can break in my sockets?
And it's not 100% necessary to break it in. You can put your tubes in there. It's just going to be very stiff, and the chances of damaging or bending something are going to be a bit higher.
Yeah. Now, we have used brand new tubes to break in. It's just not it's not the smartest.
It's not ideal.
It's not ideal. Just make sure before you start pushing in your break-in tube or your good tube that every pin is lined up. You do not want to force the you do not want to force it in
if it's not actually in the receiver.
Yeah, and I'm going to put my fat head in the camera. Oh, maybe I didn't. And I'm going to put it in again. I'm going to do that 3 times on both sockets, and then that's it. The sockets, they'll still be snug, but they'll have been broken in, and life will be a lot easier. Okay, what's the first set of tubes we're going to try in here, Charles?
Well, we've got this beautiful set of NEVZ 6N6P for the cathode follower, which is the standard tube here. And we have a 6N1P EV Voskhod rocket, which is the namesake of this amplifier.
Now, it's worth looking at the testing numbers on the 6N6P because some of you might have just picked up some poorly tested tubes and not really sure what the testing numbers mean, or maybe there's no testing numbers. So the very top 2 numbers, 102 and 103, those are the GM or mutual conductance numbers. But because we're using this tube as a cathode follower, the current that the tube will pass is actually quite important, and that's the second number. That's 37 and 38 milliamps. So notice how Charles has balanced out. Both sections of the tube are really quite closely matched. And I would like to see them somewhere about 5%, no more than 5% off, unless it's a rare 6N6P, then 10% off is acceptable.
But the vast majority of these test very tight like this. They're excellent tubes. So let's get these installed here. We're going to line it up and make sure pins are all seated correctly, and it looks like they are.
Yeah, even though we're kind of excited, take your time.
And here's our 6N1P EV, and same thing, we're going to make sure it's lined up correctly, and there we are.
Yeah, and for testing voltages, I think we're going to put the bypass in place, Charles?
Yeah, it doesn't make a huge difference.
Well, it does for gain, but we're not measuring gain. We're not measuring gain. So
all right, so now we're going to have to flip it back over, but obviously you don't want to flip it back over and have it resting on these tubes. So make sure you get something that you can stand this edge on, or you can possibly have it leaning on its side if you have something to support it.
Yeah, whatever you do though for live voltage testing, make sure you have it on the bench in a nice stable fashion.
Yeah, you don't want it to fall or rock over or anything while you're probing or in there.
And make sure you have a friend or somebody watching over to make sure that you're going to be okay. You do not work with high voltage electricity on your own. Okay, so we're just going to block this up. We have a whole pile of blocks on the bench, and we'll see you back in just a minute. Okay, so go ahead and grab your IEC cord. We're going to plug in. Now that your tubes are in, we're going to turn it on. There's no sparks or anything exciting, so while it's warming up, I'm going to show you on the schematic what we're going to do. So we're going to come along here and we're going to do test point 3 and 4 again with the tubes loaded. Now, so long as we're in the ballpark of what we're showing on the schematic, we don't need to come back to the earlier test points. You can go ahead and probe them if you want out of curiosity, but this will, if this is in the ballpark, that will indicate the circuit's working perfectly fine. And you're also going to grab the preamp circuit itself, and we're going to be probing pin 1 and 6 and pin 3 and 8, and over here
we'll be doing the same on the cathode follower.
We'll be doing pin 3 and 8 over here, and we've got test point 5 and 6 over here. So I'm going to call out, get your schematics handy, I'll call out the test points. So everything is warming up. So Charles, how about we get on to test point 3 and 4?
Okay, so that's where we were last time. So again, I'm holding the probe right at the end here, and I have my free hand in my pocket, and I'm standing on a rubber mat. So I'm going to come in on 3. And we're seeing a nice and stable voltage, 242.6.
Let's see what the other one is. So each one of these is a channel.
And here's 4. That's pretty good, 243.8.
Okay.
So that's a very good sign.
And our approximate center value on the schematic is 241. And actually, we're running this on a variac and we're 1 volt over 120. So we're just going to turn it down slightly. Okay, so that lets us know that the power supply that's from here back is working just fine as far as we can tell at the moment.
If that voltage doesn't come in where it's expected to be, stop what you're doing. It's time to start troubleshooting.
Yeah.
Okay, assuming it has, let's move on.
Okay, so let's go on to the preamp tube. That's V1.
So that's this guy right over here.
And let's check pins 1 and 6. So that's each half of the tube, and that's the high voltage plate connection.
Okay, so I'm getting 173 volts on pin 1.
Okay, and on 6?
We're getting 171 volts.
And our schematic says approximately 172. So that's
we're on either side of center there.
basically bang on. And yeah, so one of the things you should watch for is both sections should be fairly close. They're not going to be exactly close,
but within about 5 volts
because
or so.
There will be a little variation in the tubes. So pin 3 and 8 on V1.
So this is the cathode. So pin 3, so this is our bias voltage, and we're seeing 2.5 on 3.
Yep.
And pin 8, we're seeing 2.56.
Excellent.
All right.
Okay, let's move on to the cathode follower. So that's V2.
Okay.
And let's probe pins 3 and 8.
Pins 3 and 8. So we've got 102.5 on 3.
Okay.
And on 8, 103.7.
Okay, they're fairly close together. Schematic says 107, but that is just absolutely fine. That voltage is going to depend on a lot on which cathode follower tube you've got in there. Now let's check test points 5 and 6.
Okay, so let's see where they are on the board here. We've got a test point 5 up here, and we've got a test point 6 down here. So let's check 5 first. There we go. So we're reading 98.7 volts.
Mm-hmm.
And test point 6, we're reading 100 volts, bang on.
Okay, now if you want to know what the bias voltage of the cathode is, if you're really keen about that sort of thing, you can test pins 3 and 5 or pins 8 and 6. Or sorry, pins, let me try that again. You would test pin 3 and you'd go to test point 5 and you subtract them. So let's just do that quickly.
Okay, so pin 3, we're reading 101.4.
Okay, I got it in the calculator.
Okay,
And test point 5.
Test point 5, 98.2.
And the answer is 3.2 volts.
There we go.
And if we did the other side of the tube, you would find you would get a very similar result. The difference, of course, should be nice and tight. So, yeah, so all of our voltages are good. So we'll come back in a second. We'll talk a little bit about what to do if they're not.